Okay, so now that we understand how to look at a simple univariate regression, we can recognize that there are a couple of more complex analyses available to us. And so we talked about in the lecture already how one of the more efficient or appropriate ways to measure risk takes into account that there is more than just risk associated with how UPS reacts to systematic events. Okay? So CAPM says that the expected return of UPS, and thus the risk of UPS, is just the result of this formula. Right? The risk-free rate plus the beta for UPS times the market risk premium, which is the expected return on the market minus the risk-free rate. Right? And we just saw how we can describe this relationship as a line, right? Where the line is the intercept, B, plus M, the slope, X equals Y. All right, so this is the regression line that describes the capital asset pricing model, where beta is equal to the slope of the line, B is the risk-free rate, the y-intercept, and then our x and our y are the return of UPS and the excess return on the market. Now, we might say, okay, but there are more things that can affect stock return because there are more things that can affect risk. And are there any other ways that we've determined to do this? And yes, we have, right? That's what gave rise to our discussion about the Fama French factor model. And the Fama French factor model says that there can be more than one factor affecting the risk associated with UPS. And so we can say, okay, the expected return of UPS or any asset can be equal to any number of risk characteristics or risk factors. Okay? So we'll write our intercept here, and each of the factors will be denoted by their respective betas. Right? So here I'll have beta 1, and the first factor will be the expected return on the market, right? Which is the same here, right? The market risk premium, right? This is our first factor, and this is the beta related to the first factor. But there might be other factors, and we've discovered some other factors. The second one is the return on what we call the small minus big portfolio, small minus big. And this is the expected return of a portfolio of small stocks, meaning the size of the companies is small, minus the expected return of a portfolio of big stocks, meaning the size of the portfolio, the companies in the portfolio are large. So let's say I just did 50-50. I say, okay, the 50 biggest companies in the market, I'll take their expected return on average. The 50% smallest, I'll take their expected return on average, and then I'll subtract the return of the big from the return on the small. And we do this because we've discovered that there's a relationship here, that the smaller stocks tend to have larger returns. And probably this is mostly just mechanical. Small companies have more room to grow, right? We talked about growth and value and what affects that. Well, one of those things is that once the market is saturated and you're a large established company, there's not much more room for you to get any bigger. So big company stocks tend to underperform small company stocks. And so this is another risk factor. And if UPS falls into the big or the small category, that can help us determine what the expected return on that stock should be. Right? And of course, UPS is probably going to fall into the big category. So we should expect to see lower returns than for small. Okay? And then we've found another one. This is called the Fama French 3 factor. And so the third factor is the high minus low portfolio, plus some error term, where the high minus low portfolio is the difference between a portfolio of high book to market firms minus a portfolio of low book to market firms. Right. So remember that Book to market is the ratio of book equity, the book value of equity, to the market value of equity. And what this describes typically for firms is growth options. A firm that has a higher market value of equity than book value of equity means that the market expects the firm's book value of equity to grow in value, right? So this is a measure of the expectation of whether the firm is going to start to perform better. And again, we see higher returns typically with high book to market. This is the market expecting the firm to do better minus low. So depending on whether UPS is falling into one of these categories, or depending on its relationship with these categories, we're going to see different expected returns. Right? So this is similarly, and it's harder to conceptualize a three-factor line. Right? A one-factor line is very straightforward. Here's our one factor, right? We have market return, or let's do UPS here. We have market here, right? I drew my line, right? Slope of this line, right? Y equals mx plus b, right? So here's b. The slope is m, right? And we have our line. With a multi-factor model, it's a little harder, but we can easily conceptualize two factors, right? Because we go from 2 dimensions to 3. So here I could have UPS, right? And then I can have the market return, and I could have, let's use small minus big, right? So now I have a 3-dimensional space. And all I'm trying to do is define the line that best, right? Again, I'm not an artist, okay? I'm a finance professor. We're trying to find the line. The regression is the line that best fits the 3-dimensional model, right? And so we might imagine that, the 3-dimensional model would still look similar to this, and we could have a generally reasonable relationship here. Now, with a fourth factor, the fourth dimension, I don't even know how to draw that, so I'm not even going to try. But that's all we're doing, right? And the math doesn't care. We can have as many dimensions in math as we want. And I could continue to have as many factors here that I think might describe the relationship between UPS risk and return, right? And certainly there are factor models that have more than 3. The Fama French 3-factor model has proven to be one of the most reliable and certainly one of the best predictors, but it definitely does not explain everything. In fact, I think the 3-factor model explains about 12% of risk, which is statistically, that's pretty good for an economics regression, because remember, we're trying to model the risk of a real-world company here, right? Can we really ever expect to have the perfect set of factors here that describe the risk for UPS? I would certainly expect never to be able to do that. And we would then never have a model that was any generally useful, because the risk factors for UPS are likely to be similar but different to the risk factors for any other company that isn't UPS, right? So there are other factor models, and there are other ways to estimate risk, but these are the 2 of the most common, and so that's what we're talking about here.